To graph a logarithmic function, there are lots of methods you could use. I'm just going to show you one way that I think works. It's nice and quick, easy way to get the table. So we know that a log function can be rewritten a different way. It can be rewritten as an exponential equation. And since we already know how to deal with exponential equations, this is the method I want to use. I want to change that to an exponential form and then create a table based on that. So we know that if it says log base 3, then 3 is my base. And the exponent is the thing that's all by itself on the other side of the equation, which here is y. And that equals the argument of the log, which here is x. So now I have an exponential equation with the x and y switched from where they usually are. So an exponential equation is the inverse of a log equation. Remember when you switch x and y, you're doing an inverse? So to make our table here, instead of filling in our normal x values for x, we fill those normal values in for y, because we're doing the inverse here. We want to fill those in as the exponent, and then figure out what it equals. So we want to do 3 to the negative 1 power, and determine that x is 1/3. 3 to the 0 power, and determine that x is 1 here. And 3 to the first power, to determine that x is 3 here. And these points are going to go directly onto the graph. There's no horizontal or vertical translation here. So these points are going straight on the graph. 1/3, comma, -1, located about here. 1, 0, located about here. And 3, 1, located about here. Now, what's interesting about this is because it's the inverse, it's totally the opposite of the exponential graphs that we've been doing. Instead of having an asymptote that goes side to side, we're going to have an asymptote that now goes up and down. It's going to be an x equals equation instead of a y equals equation. So the asymptote here is going to be located at 0, right? There was no horizontal or vertical translation, so that means the asymptote stays at 0. And now it's a vertical dotted line, like this. And when I connect my dots, they're going to go along the y-axis like this, and then continue to grow in that direction. Okay, so this is our first log graph. The domain of this graph is now going to be what used to be like the range, because we're going to base it on our asymptote. The domain here is that x is the all numbers greater than, but not equal to, the location of our asymptote, which is at 0. And the range this time is going to be all real numbers, because this is going to continue rising, and it's going to continue falling. So the y values cover all real numbers. This one's similar, only now our base is a fraction, but it's okay, it's going to work the same way. So we're going to rewrite it as an exponential equation. Our base is 1/2. I like to put that in parentheses with the exponent outside. Our exponent is y. Again, that equals x. So when I make my xy table, I want to fill in our regular values for y and plug those all in to figure out x. So 1/2 to the -1 power is 2. 1/2 to the 0 power is 1. 1/2 to the first power is 1/2. These points go directly on the graph. Over 2 down 1, 1, 0, and 1/2, comma 1. Again, there's no horizontal or vertical translation, so our asymptote's located at 0. When I connect my dots, this one's going to be going along the asymptote up here, and then getting increasingly lower. So our domain for this graph, asymptote's still at 0, so it's x is greater than 0. And our range for this graph is, again, all real numbers, as it keeps going up and down forever. We can graph log functions of this form with h and k by simply translating our graph, h units side to side and k units up and down like we've been doing. Let's practice one. We have a log base 2 of x here. I'm not going to include the 3 or the 1 when I create my table. So I'm going to start out writing it exponentially. Base 2, exponent is y, equals x. We create our table using these 3 y values, plug them in to get the x values. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. Now these 3 points I have to shift them. 3 units to the left, because that's what h tells us to do, and 1 unit up, because that's what k tells us to do. So we're going to find 1/2, comma -1, and then shift it 3 units to the left. 1, 2, 3, and 1 unit up. I ended up here. We're going to find 1, 0. And then we're going to shift it 3 units to the left and 1 up. I ended up right there. We're going to find 2, 1, and shift that 3 units to the left and then up 1. And I ended up here. Now our asymptote is going to be located with the horizontal shift, right? Everything for an inverse function is just the opposite of what we're used to doing. So now, if our horizontal shift has moved us 3 units to the left, my asymptote is going to be located at -3. So I'm going to create my vertical line, dotted line here at -3. The equation of this line would be x equals -3, right? Our other asymptotes were always y equals equations. Now we have x equals equations. And when I connect the dots, I'm going to go skim along here and then continue rising in that direction. Our domain for this is based on the asymptote here. X is greater than -3. The range for this function is still all real numbers. It goes up and down forever in both directions. And that's it.